Fantastic stuff. So absolutely delighted to be able to welcome you to session 3 of the live presentations today at AICUR. We're going to be hearing from Rowan Fitzpatrick, then Dara Costello, and we'll also then be hearing from Ellen Doorley and Haley Hefser together. So I'm really looking forward to seeing what you're going to present over the next couple of minutes and throughout the session. And we'll hopefully have time for Q&A after each one of the presentations, and we'll stop the recording then before any of those Q&As take place. So Rowan Fitzpatrick, I'd like to first of all welcome you, and you can start getting your screen up and ready there for your presentation. So Rowan is a 4th-year sport and exercise science student here in the University of Limerick, and we're going to hear about the effects of different post-warm-up recovery durations on 2,000-meter rowing ergometer performance. So Rowan, when you're ready, take it away.
Thanks, Phil. We get my presentation mode ready. Oops.
Perfect.
Sorry there.
No problem.
Alrighty, so hi everyone, my name is Rowan Fitzpatrick. As Philip said, I'm a 4th-year sport and exercise science student at UL. I am pleased to be able to present to you in the following slideshow my final year project, the effect of different post-warm-up recovery durations on 2K rowing ergometer performance. So the purpose of this research study was to investigate whether a 9-minute or a 20-minute post-warm-up recovery period resulted in a faster 2K time. Both warm-up and warm-up recoveries have been deemed essential components to competition as they increase performance and reduce the chances of injury. The beneficial mechanisms behind these effects include body temperature, heart rate, oxygen uptake. However, all these factors have been shown to decline as soon as exercise ceases. Therefore, the optimal duration of time between an active warm-up and its subsequent performance is critical to establish for athletes to profit in competition. The current literature suggests that a post-warm-up recovery period of greater than or equal to 9 minutes and produces an optimal blood lactate level of between 3 to 5 millimoles per liter will be optimal. And we selected 20 minutes as our second duration since many swimming studies favor that duration as well. Unfortunately, the research investigating the effects of different post-warm-up recovery durations on rowing on performance is limited, such that this is the first to study warm-up recovery durations in rowing. Our participant pool was recruited from the local rowing clubs around Limerick. All were national level rowers. Their anthropometric data is listed here. The results of this research was enlightening to them as individuals and hopes to be impactful to the entire rowing community in influencing pre-race strategy for higher performance. So onto our methodology, we utilized a random crossover design. So each participant completed each condition in a random order. Testing sessions were completed on 2 separate days, each a week apart. During these sessions, participants performed a standardized warm-up, followed by the passive 9 or 20-minute rest duration, and then their 2K maximal effort time trial. During this, blood lactate, heart rate, and temperature were all taken at 3 intervals, being post-warm-up, post-recovery, and post-performance. The rate of perceived exertion was also taken after warm-up and time trial as an estimate of intensity. The data from each 2K was also recorded from each ergometer to isolate any abnormalities. Luckily, we found none. Our statistical analysis was also completed using SPSS, and I'll jump into that right now. So what we found was in the following boxes. The green highlights our primary variable of interest, being the 2K trial time presented in seconds. The p-values attained from paired t-tests showed that there was no significant difference found between recovery durations. The remainder of the variables are highlighted in yellow if there was a significant difference found. These being post-recovery heart rate, post-performance blood lactate, and post-warm-up temperature. Further statistics are shown in the bottom table, being a Cohen's d test, which found a large effect size for both heart rate and blood lactate, and a small and nearly trivial for temperature. For these two, we conducted a Wilcoxon signed rank test, which confirmed a significant median difference in the heart rate and blood lactate. For our interpretation of these results, more specifically, why despite finding no significant difference in the means between durations. As you can see, 5 of the 7 individual trials did better during the 9-minute recovery. Similarly, why are statistically significant variables leaned in favor of a 9-minute recovery duration? First, let's address our post-recovery heart rate. It seems logical to assume that heart rate would reduce more and more as the recovery time lengthens and you're just sitting there relaxing. But heart rate is also indicative of oxygen uptake, or the volume of oxygen you consume in a minute. In turn, this VO2 influences energy utilization over performance. So in other words, this means that the higher baseline heart rate, i.e. the higher VO2 at the end of the 9-minute recovery, allowed the rowers to reserve their glycogen sugar energy stores until later use in their time trial. Blood lactate was also similarly comparable in the 9-minute recovery. Some researchers suggest that a shorter rest induces increased lactate production due to glycolytic stimulation over the trial, which may be why the 9-minute post-performance blood lactate was higher than the 20-minute. There was also an association between high VO2 and lactate accumulation. Thus, the higher post-recovery heart rate linked to higher VO2 may have influenced the higher post-performance blood lactate in the 9-minute recovery duration. Temperature was not analyzed for this, as it didn't pass the Wilcoxon rank test, and it was likely due to environmental temperatures, as it was after the warm-up and not after any of the recovery or the time trials. So some concluding key points from the study. Firstly, the investigation did not yield any significant difference between the mean 2K trial times of either recovery durations. We found this very curious, as the individual trials and significant variables favored the 9-minute recovery duration. We believe that if a larger participant pool was recruited, that the mean 2K results would also support the 9-minute. And this leads us into some limitations and recommendations for future research. As with all, we did encounter some massive limitations, being that we started with a reasonably large group of participants. And fortunately, over half of those had to withdraw for various reasons, including COVID, injuries, which is always common with athletes. Hence, our primary recommendation for future research is to expand the participant pool and aim for an equal gender ratio, as ours was 5:2. We also see benefit from the holes in our research and from what was conducted in similar studies to utilize additional blood lactate collection points, a self-selected recovery duration, oxygen uptake as a variable, and an active versus a passive recovery condition. And I feel like I went really fast through that, but thank you everyone for listening, and thanks for your attention.
Thanks a million, Rowan. I'm just going to stop the recording there now before we go into any questions.